Hey guys, it wasn't bad.
It was pretty bad.
What?
Just kidding.
Well,
You weren't even here.
all right. So we are learning a few more identities today, or you might call them formulas, if you will. So we're talking about the sum and difference formulas today, and I am just handing them to you on a platter. So you need to know how to use them. So the question is, oops, I'm in the wrong mode. Okay. I have a question here in red. It's an important question. Will you please use your calculator and tell me if the left side is equal to the right side? Like, plug it into your calculator. What do you think right off the bat? Do you think that they're the same? Good. I'm glad you think that. Now, go ahead and plug it in. So left side, and plug in the left side, and then plug in the right side, and see if they make the same value. Slightly. Okay, so here is the really important thing that we want to learn today, that if I have two angles, and I add them together, is the sign of the sum the same as the sign of each added together, okay? And this is, you can understand why this is a common misconception. Like, this looks like a 2, and if you normally would just distribute it, right? Yeah. But it doesn't work that way, because sine is a whole opposite over hypotenuse sort of thing. Like, there's this whole thing going on, okay? And so these absolutely do not equal each other. And that's the first thing we want to make sure that we understand. You cannot distribute a function. It doesn't work that way, okay? And so instead, if we need to find the sum or difference of two angles, the sine or the cosine of the sum of some angles, we have a formula, okay? And this formula, it's different for sine and cosine. And I want to point out a couple of things. So A and B are the angles that we're looking at. Sometimes we're going to have to create our own angles, and sometimes we're going to use our unit circle. And so I like to use the word expand for both of these, just to help you remember that it is a big old expansion, a big old thing. So when I look at this, if I have the sine of the sum of two angles, then I'm thinking to myself, the pattern in my head is sine, cosine, cosine, sine. Sine, cosine, cosine, sine, keep the sine is what I say to myself. Sine, cosine, cosine, sine, keep the sine. What that means is if I have an addition, if I'm adding my two angles, then my sign is addition. If I'm subtracting the two angles, then my sign is still subtraction, okay? Sine, cosine, cosine, sine, keep the sign. And the angles are first, second, that doesn't change, okay? Sine, cosine, cosine, sine. And they start with sine. If I have the cosine of the sum of two angles and I want to expand that, then I think to myself, cosine, cosine, sine, sine, change the sign. Okay, so you'll notice if we have the sum of the two angles, then we use the negative. Okay, if it's a negative, we change it to a positive. So that's how I keep these straight. So if it's a sine of two angles, then sine, cosine, cosine, sine, keep the sign. If it's the cosine, 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 sine, sine, change the sign. Okay? Okay, it's like a song. Just like our sine, cosine, yes, okay. All right. So example 1. We're going to expand here. We have some problems we're going to look at here. For positive acute angles A and B, and this is important. Positive acute angles basically mean we are in quadrant 1. That's nice to know. it is known that the sine of angle A is 5/13, and the tangent, according to angle B, is 40/9. Well, I need some extra information here. So what they're doing is giving me enough information to draw a triangle. All right? Anytime they give me a trig function, I get to draw a triangle. So I'm going to go ahead and draw a triangle in quadrant 1. So I'm going to draw an angle and turn it into a triangle. This is angle A. Now they told me that the sine ratio is 5/13. What is the sine ratio? What sides are we using with sine? Opposite and hypotenuse. Very good. So we have a 5 for the opposite and a 13 on the hypotenuse. And I would really like to know the third side. How are we going to figure out the third side? Pythagorean theorem. All right, so x squared plus 5 squared equals 13 squared. A squared plus b squared equals c squared. Are you with me? Are you with us, Scott? Yeah, okay. Well, it's hard when you're talking too. All right, we're drawing a triangle. Triangles. Okay. What's x?
12.
Okay, good. And I hope you know that one. That's a nice one. That's a Pythagorean triple. Comes up all the time. All right, so 5, 12, 13. I also have another angle, angle B. Again, I want to draw the picture. Angle B. Here is angle B, again, in quadrant 1. Now, the tangent of this angle, what sides are we given if they give me tangent? Opposite over adjacent. SOHCAHTOA. SOHCAHTOA. So, again, if you are fuzzy, write it down. Opposite over adjacent. So the opposite side is 40, the adjacent is 9, and I need to find the third side. What should I do to find the third side? Yeah. 9 squared plus 40 squared equals I'm going to go with r squared. And what do you get for r? Yeah, r equals 41. Okay. All right, any questions so far on just drawing triangles? We've done this before. Okay, all right. So now that we have some pictures, now I want to expand my sum here because I can't just add A and B together. I don't know what that is. What is the expansion for sine? Sine, cosine, cosine, sine, keep the sine. Okay, so it's sine of the first, cosine of the second, plus cosine of the first, sine of the second thing. So this is the expansion, that's just the formula. And what we're going to do then is actually, well, what is the sine ratio according to angle A? Yeah, they gave us that one. It's 5/13. And then what is the cosine ratio according to angle B? So B is over here, so that's why we label clearly. What's the cosine? 9/41. Good. Adjacent over hypotenuse. All right, adjacent over hypotenuse is 9/41. And then again, back to angle A, we want the cosine according to angle A, which would be 12/13. Adjacent over hypotenuse, 12/13. And then now back to angle B. So over here, second triangle, what's the sine according to angle B? 40/41, opposite over hypotenuse. So really important that you have your triangles labeled nicely. And then, of course, once you have that done, the rest is just calculator work, which is nice. And so I'm just going to go ahead and basically type this in. oh my God, my contacts aren't working anymore. 9/41 plus 12/13 times 40/41. I'm using parentheses. You do want to be really, really careful. I basically typed it in exactly how it appears here. And then you want to math frac because It wants exact answers. 525 over 533. And that is the correct answer. Okay? Oh, you can't see that. There you go. Just the formula. I mean, pretty much. So we already have our triangles drawn for A and B. So now we just need to expand using the other one.
So wait,
Okay, for
where do you like find the change or like the keep the sign? Like, is that in the original?
yeah, up here in the formula. So for cosine, we're going to do cosine, cosine, sine, sine, change the sign. So here, the reason we change the sign is because of the order here.
Yeah.
So the plus is on top, and so in this expansion, the minus is on top. All right, and if the minus, if it was A minus B,
No, yeah, but
you get the, oh, sorry.
to know, it would be in like the B down, like right there, is like what you're gonna change is like the A plus B, like, with, you know,
So let's do the expansion. How about, yeah. So what's the expansion for cosine? Cosine, cosine, sine, sine, change the sign. So the plus becomes a minus in the middle of those. It's cosine of the first times cosine of the second minus sine of the first, sine of the second. So this is just the expansion from above, and now we actually need to put in the ratios. So now looking at angle A, what's the cosine ratio? 12 over 13, adjacent over hypotenuse. And now looking at angle B, so looking at angle B, we want the cosine ratio, 9 over 41, adjacent over hypotenuse. So 9 over 41. Got a minus sign in the middle. And now back to angle A, the sine ratio, 5 over 13. And from angle B, the sine ratio, opposite over hypotenuse, 40 over 41. And then calculator. And math frac. So, and you know, this is, you want to be careful because doing these over really sucks. So make sure you get it in your calculator correctly. All right. Math frac. And I get negative 92 over 533. Okay. All right. That's not it. What's the question?
I don't know what I
Did you change the sign?
Yes. Yeah, I did. 5 over 13, you swapped the 2. It's supposed to be 12 over 13 there, 5 over 13 there.
Yeah, one little difference makes a huge difference. Yeah. Okay. All right. So this was given sine and cosine trig values, so we have to draw our own picture. Okay. But the other time this happens is when we need to find the sine or cosine when we're given angles that look like they should be something we know, but not quite on our unit circle. Okay, so something like 19 pi over 12 could be the sum or difference of two angles. Any two angles, really, but we want to be a little bit careful. And when I was in trigonometry, it was always marvelous to me, like magical, how they figured out what the angles were. Well, really, it's just a list, and I'm asking myself, hey, what plus what gives me 19 pi over 12? So I like to show you the list because my teacher's always like, oh, it's this plus this. And I'd be like, why? And okay. So what we're doing is I'm simply saying, hey, 1 pi over 12 plus 18 pi over 12, does that equal 19 pi over 12? Sure it does. Okay. Is pi over 12 on our unit circle? No. Is 18 pi over 12? It is. It actually reduces. And that's what we're looking for, okay? So I'm going to try another one. 2 pi over 12 plus 17 pi over 12. Does that give me 19 pi over 12? Yes. Is 2 pi over 12 on our unit circle? It is. It reduces to pi over 6, but is 17 pi over 12? No. Okay, let's try another. 3 pi over 12 plus what? 16 pi over 12. Gives me 19 pi over 12. So I'm just creating a list, right? That's not too hard, right? Okay, let's see. Does 3 pi over 12 appear on our... Okay, so that one reduces to what? Pi over 4, okay. And is 16 pi over 12, does it reduce? To what? 4 pi over 3. They both divide by 4. Okay, so these are two good choices because now I have the sum of friendly angles. Now I can use my unit circle to answer my questions here. And so I can rewrite 19 pi over 12 to be pi over 4 plus 4 pi over 3. Do you have any questions about how I came up with those two numbers? I hope it was clear because it was dirt to me when I was in high school. Like, I was always like, how did you get those? Because they just go right there, and I'd be like, what? Okay. Lists are nice. Okay. Okay. So now, again, I can't just find these things. I have to expand. What's the question, Thomas? Thinking? Taking a moment? Okay. All right. What's the expansion for sine? Keep the sign. Good. So sine of the first angle times cosine of the second angle. Keep the sign. Sine, cosine, cosine, sine. So cosine of the first angle times sine of the second angle. So I'm plugging in my angles there. And now I just get to use my unit circle to clean it up. Okay. All right. So, of course, these are kind of like, why do we still teach this? Because my calculator knows the answer just fine, right? Right, it does. It really does. However, we're not going to get a decimal that the calculator can put as exact. So these are going to give us exact answers. And this is how things were done before the dawn of calculators. So anyway, I am using my unit circle. So on my unit circle at pi over 4, my ordered pair is what? Root 2 over 2. Good. My other angle is 4 pi over 3. So 1 pi over 3, 2 pi over 3, 3 pi over 3 right here is 4 pi over 3. What's the ordered pair at 4 pi over 3? Good. Negative 1/2, little shorty, and then the longy, negative radical 3 over 2. All right. So now that we have our values, now we can figure out what is the sine value at pi over 4? Radical 2 over 2. All right. Now the cosine value at 4 pi over 3. Negative 1/2, that's the x-coordinate, so negative 1/2. Plus the cosine value at pi over 4. Right here, root 2 over 2, yep. Radical 2 over 2. And then the sine value at 4 pi over 3 is negative rad 3 over 2. Negative radical 3 over 2. And that is a negative in there that maybe you can't see too well. There we go. Negative root 3 over 2. All right, now this is where you got to know your math because your calculator doesn't do this. Multiplying straight across, radical 2 times negative 1 is negative radical 2. 2 times 2 is 4. On the second term here, negative radical 3 times radical 2 is what? Negative radical 6 over 2 times 2, which is 4. This is a perfect answer but you can also make it just negative root 2 minus radical 6 all divided by 4 as well. They are identical. Okay. Questions on that one? All right. So now that you know the positive one, how do you do one where cosine we have a negative angle? Yeah, we could subtract. 1 pi over 12 minus 18 pi over 12. We could that gives us negative 17 pi over 12. Does it work for us though? Doesn't really help us. What else could we do? What, 2 and... we can do negative angles, yes. I just kept counting up because I'm not a negative thinker, like, and generally I'm always positive. Did you get that? Wasn't that great? So, I mean, I can't keep, there's an infinite number of angles that add to this, or in this case, subtract, but, so what, negative 19 pi over 12? And then, well, that didn't work either. So 3 pi over 12 minus 20 pi over 12? That'll work. So again, I'm just going with what I know, all right? And are we all going to do it the same way? No, there's a million answers here. Literally a million, billion, trillion different ways to do it. So this one works for me. That gets me negative 17 pi over 12. So I'm going to go ahead and reduce that. So cosine of pi over 4 minus, we're dividing by 4, 5 pi over 4, right? Because we just had to, 3. Yeah, we're dividing by 4, top and bottom. There we go, okay. So no, this is a subtraction, so we just have to change the sign, and then we think of the angle as positive. All right, so now, what's the cosine expansion? Cosine, cosine, sine, sine. All right, so cosine of the first times cosine of the second, and we don't have to worry about the negative, that minus sign is part of the formula, so we're going to change the sign so it becomes plus cosine, cosine, sine, sine. So sine of pi over 4 times sine of 5 pi over 3. Cosine, cosine, sine, sine, change the sign. That's how I remember that. All right. So, I get to use the same pictures, right? 1, 2, 3. Oh, no, not quite. All right. I'm just going to redraw. Here we go. That's the pi over 4. And 5 pi over 3, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. Here's 5 pi over 3. What's the ordered pair at 5 pi over 3? Good. Negative radical 3 over 2. And the other one's rad 2 over 2. Okay, perfect. So cosine at pi over 4 is? Root 2 over 2. All right, cosine at 5 pi over 3, yeah, 1/2, plus sine at pi over 4, root 2 over 2, and sine at 5 pi over 3, negative radical 3 over 2. Good. Now the multiplying part is super easy, it turns out. Radical 2 over 4 for the first, and the second becomes negative radical 6 over 4. And look at that, they are almost the same. Interesting, huh? You suppose you can check your answers?
Yeah, probably.
Yeah, for real. So in my calculator, the original problem was the cosine of 17, or rather negative 17 pi over 12. Okay. So there's our approximation. And again, you can math frac that all you want. It'll never work. okay, because it's totally irrational. If I type this in, I'm using parentheses, radical 2 minus radical 6, whoops. So that's the numerator divided by 4. Yay! Can you check your answers? Yes, should you check your answers on a test? For real? Okay. Do you have questions for me? What's the sign expansion? What's the, keep the sign, good. And what's the cosine? Change the sign. Excellent, good job. You got this.